Okay, so in this project, we're going to still do an application of trigonometry to a physics problem. As we've said before, we need to remember SOHCAHTOA. This will help immensely, again, in solving problems, especially when angles are not defined from the useful perspectives. So here's a problem that we might look at. Suppose we have a simple pendulum. And we're given this angle theta. Okay. And it may not have been released from theta. It may have been released from somewhere else. So I will put that on here. It's released from some initial angle theta naught. And let's say at this point we want to find the acceleration and we want to find forces. And we might want to find the tension in the rope. Okay, so we're going to look at this object and we're going to draw some forces. So I'm going to do this in green. So we know that we have mg always acting downward. And again, we're just going to take m equals 2 kilograms just for fun. The other force we have acting on this is this tension T. Okay. What are the coordinate directions that we're interested in this problem? Certainly coordinate directions like x and y are not going to be very useful for us. But what will be useful for us is a coordinate direction in the direction of motion. I guess I should do that in a different color. So let me just erase that. So I will do the coordinate directions in white. So the coordinate directions are this and this. So the white represents a coordinate system that we could call x and y, but it might be better to call it, tangential and perpendicular. Okay, so for this kind of problem, we're going to need to identify forces. So what I would do at this point is try to make the coordinate system something that I can understand a little bit better. So I'm going to redraw it with this as the tangential and this as the perpendicular. If you want to think of them as x and y's, you can, but you certainly don't have to. Now that we've done that, we need to draw the forces on this particular coordinate system. So first let's look at the tension T. The tension T points in what direction on this coordinate system? We can see that the tension T only points in this direction, the positive perspective. What about mg? Does it point in either of the perpendicular or tangential directions? And the answer is no. It points somewhere, if you want to look at it, kind of like a third quadrant. So mg actually points like this. And again, sometimes it helps to just physically in your mind turn the system. And if you turn the system in your mind from this system to this new system, sometimes then it's easier to put the angles on. Okay, so now we have to figure out some angles, especially the angle for mg. And we have a couple of choices. We can go with the angle with respect to the tangential axis or the angle with respect to the perpendicular axis. And I'm going to choose to try to find this angle theta. Okay? So if we go back and do a little bit of trigonometry, we can see that that angle, okay, pointing downward, is actually equal to theta. The original theta in the problem. So the green theta equals the red theta. Okay, now I'm in a position to find components. The upward component for t already points in the perpendicular direction. So the only thing I need to do is find the components of mg that point in the two relevant directions. And the relevant directions are what component is in this direction and what component is in this direction. Okay? So here's where I'm going to take my triangle and redraw it. Okay, and here's mg, and here's theta. And we can put in a value for theta if we want to. Let's say theta equals 30 degrees. Okay, so now we make a triangle. And the right triangle that we make gets completed by drawing this line. Okay, so now we have a right triangle. It has two sides, the two blue sides. And now we need to use the SOHCAHTOA rules to determine this is F in the perpendicular direction, and it points downward. And this is F in the tangential direction, and it points to the right. So if we do our trig on that, let's rewrite the triangle. Okay, so now we have the triangle isolated, okay? And again, we remember these F perp, F tangential, but then we need to find them. So we go with some trig rules. F perp over the hypotenuse, which is mg, has to be equal to either the sine of theta or the cosine theta. So that's going to be, because it's an adjacent over hypotenuse, that's going to be a cosine theta. Whereas F tan over the hypotenuse is going to be your sine theta. Okay, we can solve both of these for F perpendicular, which is equal to mg, so we were using 2 times 10 times the cosine of theta, and F tan is equal to, in magnitude, so might as well use magnitudes, and then we'll get the sine straight later, is equal to mg, which is 2 times 10 times the sine of theta. Now, since we had decided that theta was equal to 30 degrees, we can plug in some numbers here. So this is 20 times the cosine of 30, which is 20 times 0.866, which will pop that in our calculator. And this one is 20 times the sine of theta, which is equal to 1/2. Okay? And we get 10 for this and 17.3 for this. Now we can go back to our original picture. So our original picture, and I'll just pause.